Hello, this is our final presentation for Group 15. Our project's name is Cloud MX Operations Center. This section will go over our project's goals and is broken up into two sections, the problem description and the problem objective. Here is the problem description. The sponsor of this project is Brandon Rhodes, who is the major in the U.S. Air Force. He leads a squadron at Dobbins Air Force Base in Georgia. Major Rhodes and his team uses spreadsheets to write down information pertaining to the aircraft's location on his squadron's hangar and adjacent runways, such as the maintenance status of each aircraft, where it's located, and the overall flight schedule. The problem is that this is a very inefficient system. Most of the members are not near a computer at all times, and spreadsheets need to be printed out and handed to the major and other members several times a day. Using spreadsheets is not is also not useful for looking and editing in this environment, as critical information is compacted into just a few cells and can sometimes be hard to view and even lead to confusion. There is also the issue that the security of these spreadsheets and the database that stores all their data is not very secure. Our goal is to create a smartphone application that will give relevant real-time information about aircraft in the hangar or runway to anyone who has the application on their smartphone or tablet, whether it be iOS or Android. This will allow the airmen in access to this will allow the airmen to access the critical information wherever they are, since they have a smart device on their person at all times. The application will also be encrypted because the information stored on these devices are not classified, but are still sensitive data that cannot be shared with outside parties or cannot be leaked to other entities outside of the armed forces. The application will contain the status of the aircraft, whether it has maintenance issues, who is the lead maintenance technician, and other comments about the aircraft. It will also contain the location of each respective aircraft on either the hangar or the runway, the overall weekly flight schedule for each aircraft, and if there are any physical problems with the hangar that need to be repaired. There will be a separate admin and viewer modes in which the operation controller can update and view that in the admin mode, whereas everyone else can only view the data. Our objective is to write the application in React Native so that the we have both the iOS and Android apps based on one universal code base instead of two. We will also be using Amazon Web Services for the server and to store the data. We believe that the creation of this smartphone application fulfills the needs of our beneficiaries tremendously, as it solves all their problems that they discussed to us.
This section shall break down the objectives of the Cloud MX Operations Center. These requirements are a high-level description of what the Cloud MX Operations Center will be at the end of its development. These requirements are organized into three sections: functional, usability, and safety requirements. Functional requirements are what the Cloud MX Operations Center system will be able to accomplish. Usability requirements are what the user will need in order to interact with the system. Safety requirements are meant to make sure that the system is safe to use by the users and the organization responsible for it. Additionally, we will go over the requirements that couldn't be met and the requirements that were added during the development of this product. Functional requirements. F1. The system shall display up-to-date information related to all the aircrafts. Function 2. The system shall display up-to-date information related to the relevant buildings such as hangars and AGE. Function 3. The system shall display up-to-date information related to the maintenance workers that work on the aircrafts. 4. The system shall contain a database where all information is stored. This will be stored in AWS. And requirement 5, the system's UI will have a digital representation of the Dobbins Air Force Reserve Base that users may interact with to see the information displayed. Usability requirements. Requirement 1, the system shall be a mobile application where all related information may be viewed and updated. 2, the system shall be supported by both iOS and Android devices so that all people can access it with both phones with those operating systems. 3, the system shall need an internet connection in order to use it because we are using several databases that are connected to AWS. Admins can make changes to the database to the mobile applications. And lastly, regular users will only be able to view the information within the application while they cannot change anything within there. And 90% of the users will be viewer mode only. The system will be encrypted as our sponsor said so because this is a very important app that should not be able to be hacked by any other third-party group because it contains sensitive information. And the system shall have admin and user privileges, meaning that the regular viewer users should not be able to update or change any of the sensitive data. Only the admins can do such a thing. Project requirements not met. While developing new requirements were found, however, we had to make sure that the requirements that we already defined were met. These requirements could not be implemented to further improve the overall system. The system shall display the status of the equipments. The system shall contain a password recovery feature. The admins can add equipment to the system through the mobile application, and admins can update equipment from the mobile application. These features can be implemented in the future by a group that works on this application.
Alright, here's a block diagram representing our subsystems. The backend section deals with how information displayed by the system is edited and how users are added to the system. The arrow from the database box pointing to the admin box shows that the admin or admins will already be part of the Cloud MX Operations Center. The arrow pointing from the admin to the admin's device shows how admins view the mobile UI from their device. The arrow pointing from the admin's device to the mobile UI shows that admins can edit information within the mobile UI. The arrow pointing from the mobile UI back to the database shows that changes made by the admin within the mobile UI is sent to the database to update it. The arrow from the database to users represent how each user of the system is manually added into the system by the admin. Traditionally, a sign-up screen would be provided, but since the information presented by this Cloud MX Operations Center is considered extra sensitive, extra care must be taken to ensure security. The front-end section deals with how information is displayed to the user. If a user has been added to the system by the admin, they can use the device to see the mobile UI. The arrow from the user to the user's device represents the transaction between backend to frontend and how users that are part of the system may see information stored within the database. This is what the arrow pointing from the database to mobile UI means. Information from the database is sent to be displayed in the mobile UI. The aircraft info, building info, and worker info boxes represents the types of information that the mobile UI will present. The arrow from the mobile UI pointing to the user's device represents the mobile UI being displayed on the user's device. The arrow also indicates that this is a one-way interaction. The user will not be able to change any information within the mobile UI. The mobile UI is purely for viewing purposes in terms of the user end.
The diagram to the left shows the process of how the admin interacts with the mobile UI to change data within the database. An admin logs into the mobile UI. The system will first verify if the admin used the correct information to log in by checking the database. If the login information matches what is in the database, then the admin is allowed into the mobile UI where they can edit information and add or remove users or other admins from the system. Any changes made will be sent to the database to reflect the changes. The diagram to the left shows the process of how users will interact with the mobile UI in order to view information provided by the app. The user inputs their login information, and the information is sent to the database to verify if it is correct. If the login information provided matches the one for the user in the database, they are permitted to view the mobile UI. This is where users can view information that is stored within the database of the system.
I will be talking about our use case diagrams. The figure on the left shows the use case in the perspective of the admin. The admin can log into the mobile UI, which is sent to the database to verify. If verified, the admin can edit information, add/remove users, and or admin. All changes are sent to the database to reflect the changes, and the users and or admin previously not added before are now part of the system, or if existing, are removed if deemed so. This case shows the flow of the backend state diagram. The figure on the right shows a use case in the perspective of the user, anyone who isn't an admin. The user can log into the mobile UI and, if verified, may view information that is stored within the database, such as aircraft information, hangar information, etc. This case shows the flow of the front-end state diagram.
The next section will be about the project implementation. We'll be discussing hardware, software, front-end, back-end, database structure, and API details. This project is mostly software and assumes that the users have the necessary hardware. The only hardware that is needed is a mobile device such as a phone or tablet, regardless of it being iOS or Android. It is preferable that the phone or tablet that is being used to run this application is no more than 6 or 7 years old, as older devices may not have the capability to run applications as efficiently as newer mobile devices. However, Generally speaking, all mobile devices that run on the iOS and Android operating systems will be able to run this application. This project will be mostly software and will need a lot of software components. CloudMX Operations Center system needs to be displayed on a mobile device for both iOS and Android devices. The mobile devices that will run this application must be updated to one of the more recent versions of Android and iOS for the application to work properly. Information displayed needs to be secured as well, since they are considered to be sensitive information. There are two aspects to the software portion of this system. There is a front end and back end. The front end is concerned with how information is displayed on the app of the system, and the back end is about functionality of the app and how it will connect to the system's database. The teams that will work on either the front end or the back end portions of the app. The team that is working on this project will be divided into two sub-teams, and each sub-team will work on either the front end or back end portion of the app, because that is the most efficient approach.
For the backend, the following team members will be responsible for this portion of the implementation: Charlie Leandre, Nathan DaCosta, and Andy Nguyen. The backend portion of the system has a lot of aspects. The database portion and how the information from the database connects to the iOS and Android versions of the app. The database we plan to create will be done by AWS because it provides encryption for data being sent from and to, which is important for our sponsors. It also has backend support with React Native, which will make it easier to connect the mobile app with the external server. The database itself will store all information relating to the app will be implemented by Charlie Leandre. The other aspect to backend is how the database will connect with the iOS and Android apps for the system. Nathan DaCosta will be responsible for how the iOS app will connect to the database, and Andy Nguyen will be responsible for how the Android app will connect to the database. This will primarily be done through API calls made in Lambda and connected through API Gateway, both provided by Amazon Web Services.
All the information that the app will display will come from a database, and any changes performed to the information within the app by the admins are reflected in the database. The admin table will contain the names, usernames, and passwords of all admins. Only admins can make someone an admin. Anyone listed in this table have the power to make edits to information provided by the app. Admins can be added by other admins from the app. The user table contains the names, username, and password of all users except for admins. Anyone listed in this table can only view the information displayed by the app. Users can be added by an admin from the app. The aircraft table contains all information about the aircraft: serial number, status, last flight, sortie type, remarks, estimated time of completion for maintenance or ETIC, and parts ordered or MICAPs, location, and the lead maintainer's name. When an admin makes changes in the individual aircraft info screen, the changes will be reflected in this table. The building table contains all information about buildings and parking spots for the aircraft. When an admin makes changes in the building info screen, the changes will be reflected in this table. The maintenance history table contains all maintenance history for all aircrafts. It has the same fields as the aircraft table. When the admin updates the aircraft's information, the changes are inserted into the maintenance history table as a new field. Maintenance team table contains the name of the lead maintainer and serial number of the aircraft that they are assigned to. The Aerospace Ground Equipment or AGE table contains the name and status of any equipment used for aircraft maintenance.
The API calls are how the app and the database communicate with each other. It allows the app to display data from the database and send changes to the database. /admin resource will check if the username / password combination is in the admin table. /admin /create resource will add a new admin in the admin table. /aircraft resource selects everything from the aircraft table. /aircraft /add resource will add a new aircraft in the aircraft table with the specific information. /aircraft /remove will remove a specific aircraft in the aircraft table. /aircraft /update resource will update a specific aircraft information in the aircraft table. /equip resource will select everything in the age table. /equip /add resource will add a new equipment in the age table. /equip /update will update a specific equipment in the age table. /location resource will get the serial number of a specific location. /maintenance history resource will select everything in the maintenance history table. /user resource will check if the username / password combination is in the user table. /user / create resource will add a new user in the user table.
Hello, this is okay. Hello, this is group 15. This is our demo for this is our final demo for our Cloud MX Operations Center project. I'll let Mohammed take over and he'll run you through the app.
All right, hello, this is our app. Right now I'm signing in as a admin. Right now it's logging in as an admin. And this is our map screen. This has all, you can add new users, look at the maintenance screen. We have all the hangars 1 and 2. It gives us the serial number for the aircraft that is in that hangar. And also if you go down, we have all the different buildings, such as maintenance bay and the ramp. And the ramp also contains 1 aircraft per spot. And if we go to the top, and if we go to the hangar section, we can go to the hangar and it will show us the hangar screen, which has the building status and all the other information about the building. Now we can also go to the view all aircraft screen, and this would contain all the aircrafts that are in the area. And so, for example, if I would click on aircraft 1, it would give me all the information here, and I can actually update any field here. So, for example, I could change the remark to no, and change the maintainer to Joe. Hit update, and you can see the update work, no and Joe. And then, so if I go to the maintenance screen, it would give me all the different maintenance history of each single aircraft. The sortie type, my caps, and everything else the sponsor wanted. And also we can also add a new admin user and a viewer user. Remember, the admin can change anything, but the viewer has limited access to everything. And also we can have one where we can add aircraft and delete aircraft. And we also have, and we also have an ability to go to all the aircraft directly from the building from the map screen. And
Yeah,
I believe
and that covers that covers all the functionalities we have for the project. Thank you so much for watching. You go ahead and stop this